In this section, you'll put your knowledge of neurons into practice to create a TensorFlow.js web app that will train a custom model live in your web browser. So first, let's define a problem you'll be trying to solve. Imagine a customer comes to you and says, I'd like to create a web app that could estimate the house price of properties in a certain city. All right, well, this sounds like something you could probably try and make with your existing knowledge. In your mind, you know that property prices might be linearly correlated with certain features like the size of the house. But first, you'll need some data to see if this works well. Now, after asking the customer for more information, you find they've gathered some example data of houses in their area. Here's an example of the data provided. Now, the full size of the table is over 2,000 rows of data, so it's shortened here, but essentially it contains size in square feet, number of bedrooms, and the value of the house in dollars. Seems like there's enough data to give it a try. At this step, you may want to check the data to ensure there are no potential issues with how it's been recorded, like missing values. There are many ways to do this, of course. If there's a small amount of data, like you have here, you can visually check the columns that a value is in each, or write a small bit of code to show the min-max values and check for null values as a starting point. There are even third-party libraries that exist that can do much of this work for you and much more, but those libraries are outside the scope of this course. However, if you're interested, you might want to check out another library called tensorflow.js that makes working with data easier in JavaScript, that you could use as part of your TensorFlow.js pipeline for processing data. It tries to replicate a library known as pandas, which Python developers quite often use in data science in order to understand their input data features better. For this exercise, the data is already in good shape, so let's start analyzing what you have. Now, you can start by visualizing the correlation between each column of data that you have and the target value you're trying to predict. Here, you want to predict house price, so let's plot all the other values versus the house price to see how they relate. First, you plot size versus the value of the house as shown here. Now, how did I draw this graph? Well, you can use any graphing library of your choice to plot a chart like this. I made these scatter plots using a library called Plotly, which is well suited for JavaScript and is built upon the very popular and powerful d3.js library for data visualization. It should be noted that TensorFlow.js has a simple visualization library you can use too that you can import via a script tag. Check the links for more information. So, back to the data then. It seems that generally speaking, ignoring some of the outliers highlighted, the larger the house, the more its value, which is somewhat as expected. You can also see that these features could be correlated with a straight line, so it's well suited for linear regression, which is what we're going to be doing. Next, you can plot bedrooms versus sell price, which also shows a linear correlation between value and number of bedrooms. It should be noted that you can see the variance quite nicely here. You can see that for each bedroom level, the house values can differ with a range of about $100,000 in value. Again, there are some fairly clear outliers which you may want to consider dropping from your dataset to achieve better results. Now, there are accurate mathematical ways of finding which points constitute to being outliers, which you can then safely remove, but again, that is beyond the scope of this course, and we'll be diving deeper into the world of data science instead. However, a quick search will provide many resources on this subject if you're interested, that you can then replicate in JavaScript as needed. Intuitively then, if your chosen line is going through the central points of those distributions, the maximum error you would expect would be around $50,000, either above or below what the line itself predicts. So hopefully your trained model will have an average error lower than this. Okay, so given the strong correlation in both chosen features, along with the fact that they both seem to be linear in nature, they should be well suited for a single neuron to learn from. So now head on to the next section where it's time to start coding.